For question 5 of part 2, we are given if f of x equals x cubed minus x, we need to find f prime of x using the definition. So by definition, we need to do limit h is approaching 0, and we are using the definition, so we are using the equation to find the derivative of this rather than using the easy way. So we have f of x plus h minus f of x over h. And this is our equation using the definition to find the derivative. So now we can plug in our equation. So we have limit as h is approaching 0. We have x plus h cubed minus our f of x, or minus x. So we plug back x plus h again, and then we subtract our f of x entirely. So we have minus x cubed minus x on the very end. And this is all over our h. So to simplify this, the first step is to do x plus h cubed. So I'll do that over here. So we have x plus h cubed, and this will give us, we know that we will have an x cubed, and we know that we will be adding an h cubed. But for the in-between, we know that we will have a 3h squared times an x, and the same just for x, plus a 3h times x squared. So this is the simplified version of x plus h to the third. This is factored out. So we can now plug this back into our equation to give us limit as h is approaching 0. So then we have x cubed plus h cubed plus 3h cubed, or squared, x plus 3hx squared. We're subtracting an x, we're also subtracting an h, and then we're subtracting our x cubed, and we're adding, because a negative and a negative is a positive, an x. So we have an h, we have an x, we have an x cubed, we have our negative x. So our negative x can cancel with our positive x. Our negative x cubed can cancel with our positive x cubed at the front. So we are left with limit, and this is all over h. So we are left with limit as h is approaching 0. We have a 3hx squared in the top plus a 3h squared x plus an h cubed minus an h. That's all divided by our h. We can now bring out an h on the top. So we have an h times 3x squared, to get rid of this h right here, plus 3hx, we got rid of an h right there, plus an h squared, we got rid of an h right here, minus 1. And this is still all over h. The reason we bring an h value out is because we have an h in each one of these terms. So we know we can bring it out. We want an h by itself out. That way we can cancel h on top and cancel h on the bottom to be left with limit as h is approaching 0, 3x squared plus 3hx plus h squared minus 1. We know that by definition, limit as h is approaching 0, we know that anywhere we have an h in our equation, we need to plug in 0. So let's do that. We have a 3x squared plus 3 times 0, x, plus 0 squared minus 1. These end up 0, so we can cancel those. We do not need those in the equation. So we are left with limit, as h is approaching 0, 3x squared minus 1. And this gives our final answer. Now to check this, we can use the simple way of finding the derivative of x cubed minus x to make sure that this is in fact correct. So we have f of x equals x cubed minus x. We bring down the 3 to the front for our coefficient. We have x, and we have 3 minus 1, and minus 1. So we have 3x squared, and our negative x, we can bring that down to have our 1. So a negative 1, and then 1 minus 1 is 0. So x to the 0 is 0. So we do not have an x value. So that is how we check that we were right, and we were right. So f prime of x is equal to 3x squared minus 1.